Hello everyone, thank you guys so much for coming out. I know it's a little bit far down, but it's definitely worth the trek. Today we have Tony Casparro, who's going to be talking a lot about our latest redesign of the website. It was a lot of work, we did it in a very short amount of time, and we tried a lot of new things, all at the same time. It turned out pretty well, and we learned a lot of things about React along the way. So without any more time up for me, here's Tony.
Thanks, Chris. So thank you all for coming out tonight. We're really excited to have you here and share the learnings that we've had building the new UI in React for the past year. And so let's jump right into it. I want to take you first through the UI to talk about where we came from and where we are now. And then we'll go into the technical details of the challenges and the advantages we found building this new site using React. So let's go back in time 1 year to the old Netflix UI. You guys might remember this one. I want to point out a few features that were particularly challenging in this old UI. First one is that the overall look and feel is kind of like this old DVD kind of box art feel. There's not a lot of rich imagery to draw you into the content. Overall, you're kind of seeing what you would see in an old movie store. If you hovered over a title, you'd get kind of this layer that would tell you more about this movie. But if you wanted any more information than that, you would have to go to a brand new page, and you'd lose all the context that you previously had. It was time for some change. We were talking to design, we were working with them over the course of some time, trying to come up with a brand new UI that we felt would be really immersive, right? We have all this rich imagery. We have all this great content. How do we really show it off? And so I actually want to show you one of the early prototypes of what we thought the new UI would look like. So in contrast to the previous one, it's a dark theme, more cinematic feeling. We have lots of big, rich imagery overall showcasing the content. And then instead of the old school box art titles, we'll show you like nice horizontal ones. Once again, kind of giving you this cinematic feel. And in terms of actual UI, if we scroll, getting some lag there, that's nice. If we scroll down the page, that's not going to be good. The usual box arts. And if we hover over a particular title, instead of showing you this kind of feature off to the side, we would actually show you in line some more contextual information, maybe in a slideshow, showing off that rich imagery. In terms of the actual slider mechanism, instead of scrolling you one by one, let's scroll you an entire page, right? Let's help you move through that content. We don't want to cause any friction from you browsing that overall catalog. I'll move out of the way for you guys. And lastly, instead of this idea of like going to a brand new page to get more information about a movie or to watch a particular episode, what if you could click on this thing and it would inline Jawbone and expand in place the overall content of the title you're looking at? The idea being you're right in line with the content you were looking at right up here. This expanded down to give you all the extra information you need, including episodes and similars. So in terms of the actual code base, we were dealing with a pretty slow time interactive. The code base had gotten quite large, and we're looking at about a 5-second load time. In addition, the time to build, so the time on your local machine where you say, I want to try this change and actually see how it comes up, was up to 20 minutes to cycle that through and watch that change come up. Horrible for iteration and trying new stuff. And then lastly, it was slow to add new features. And being a big A/B testing company and wanting to try new things and trying different things out and use bleeding edge technology, that kind of iteration cycle was way, way too slow. So we were looking at a big change. And we said, okay, we're already planning on using Node going forward to build our new UI. And let's talk about what frameworks we can build on top of this, right? Okay, so we can use jQuery, Backbone, there's this React thing as well. And so what our manager actually did is he actually put some people together, and they were going to spend 1 month building the new version of the UI in different constructs. So one team built jQuery and Backbone, another team built it in React, and after that time they were going to come back and say, hey, what do these code bases look like in terms of readability and complexity? And considering that as well, we were really looking for a framework that would kind of match the beauty of the UI, right? Something that was going to be clean and simple and easy to use. And the winner was ultimately React. When it came back, the code was much more readable, it was much more modular in style, and as far as like A/B testing and changing things, we could just kind of switch out components, try this over here, move that, and that led us to really say this is a great framework for us moving forward. So we said we'll adopt React, and over the course of a few months, we built the brand new version of the UI. When we released it, we started doing some A/B testing with it. We wanted to see what worked, what didn't. We did a lot of iteration. We got those fast cycles. We sat with product and design, and we got to do that over a course of a few months. and we ended up with our final version being released a few weeks ago to great success. People are very happy so far with the new UI. It's gotten great press, and this is a UI that's big and immersive and completely built in React. So we're very, very proud of it and the result. So if you haven't seen what the new UI looks like, let's get everybody on the same page here. This is how it ended up turning out. So once again, big, beautiful imagery. And if we scroll down the page, oh, we're getting lag from the video recording. I apologize, but you'll have to imagine it's very, very smooth. As you hover over a title, it's showing you like an inline slideshow. Like, hey, we've got these assets, right? Let's show off information about titles you may not have considered before, right? Let's reduce that friction of showing you all the stuff in the Netflix catalog. As far as the Jawbone effect, we'll have it open up right in line here. Provides all the extra information you would need as far as the episodes you don't watch, sims, details, festival views, the actual reviews of the content, everything you need right in line. And then lastly, if we close this up and we actually show you the slider effect, there we go. You'll actually see a nice smooth animation for the full page view. Once again, I promise it's very fast when it's not recording, but it's a full animation of the actual row translating over. So once again, we were very happy with the results. So given the history of where we were and where we came from in terms of our UI, let's talk about the meat of our conversation tonight, which is React itself. Where was React really, really helpful for us? And what were challenging parts? And I've got a lot of great animations coming up to kind of show you what we were doing there. So, where React excelled. Now if you're using React, you know a lot of these, but these were the ones that were particularly important to us. The first one is the reduced code base size, right? So instead of having to deal with a bunch of extra controllers on the front end, dealing and manipulating state, we can throw all that out and dramatically reduce the complexity of our overall code base. And with the reduced complexity of the code base and making everything cleaner, we brought our time to interactive from 5 seconds to 1.5 by just reducing the overall complexity. Readability was better, modularity, moving things around. Once again, I said like A/B testing, we can swap components in and out. Very, very useful for us for trying new things. We also got isomorphic code out of it, right? We were going to use Node, so why not build this to render on the server and the client? Isomorphic or universal code, right, is the idea that, hey, I can write all of my code in one spot. Let's have it render on the server and the client in exactly the same way. As far as bringing people up to speed, we no longer had to bring people over and teach them struts or teach them a new templating language. We just said, hey, you already know JavaScript, you know all the syntax. There's a few new things to pick up, but overall, we can get you ramped up to speed very, very quickly. And then lastly, adding new features. So we definitely took advantage of like the React hot loader, the ability to do inline changes and do very, very quick updates. We can now sit down with product managers, with design people and say, hey, let's just try that thing you were talking about out. Let's try it in this meeting right now. And we can do those inline changes. And that's been hugely powerful, not only for the rapid iteration, but also for like, our communication, working with those teams to show that we are interested and it's actually kind of fun to build great UIs. So, the meat, though, is what was challenging. We all know the great, but what was the challenging part of the code? And the first one was, while isomorphic code was great on one end, there was definitely a challenge in bringing people up to speed on the best practices when doing isomorphic code. The idea of rendering it both on the server and the client. And specifically, when you have people that have primarily written JavaScript only for the client, and you say, hey, just start coding on the server side, there are some best practices that you should know about. And there are definitely things you can get away with when you're on the client that can be very disastrous when working in the server-side code base. And one of those is leaking context. It's very easy in a client-side code to say, I'll just set up a global variable, I'll just start using this around, and in a server-side context, it's very, very bad. And I want to bring up a solid example of some code that was written and to showcase what can potentially happen here. So, consider this a main body, right? This is just a component that was loading kind of the main view of a page. So somebody had put a keep notifications open kind of variable at the top of the page because when this component went away, they wanted to make sure that when they came back, they were in the right state. The initial state was being pulled off of the context, but that never changes because that's how it's loaded on our page. So they're saying, let's just load some state up at the top of the page and we'll do some mutations on it. And when this component comes back, we'll know exactly where we are. Now, the way Node will load this is that will be instantiated just once. And for the rest of the server calls happening on the server side, that variable is the same variable for all users. So once this variable gets set once, anywhere in this code by any user, every other person in that entire, until that node instance crashes is going to get that exact same variable, and it will stick. It's very, very bad. A solution might be saying, okay, if that's our previous main body, you're basically trying to put state where it ought not be. And React gives us a great way to do this, right? With an actual state on the top level components. So hey, don't try to use global variables. Make a higher level thing, maybe called app, or something that's going to be always around inside of your application, and say, we'll put the state there. We'll give you a hook to manipulate it as needed from down below. But overall, we don't need to store state outside of our existing content and module. Is that clear for everybody so far? No? Okay, maybe? Okay. So we'll have questions at the end just in case it wasn't. Next thing is state flow. And since speaking of props and state flowing through your application, there are times when you're writing your code and you're actually looking at your application and you're going, I have no idea why this thing is re-rendering so much. What is happening? And so, especially as your applications get larger and larger, it's kind of hard to keep track of what's changing things and why. So what we did is we actually built something called the React Visual Renderer. And what this does is it's a mix-in, and you can include it on any component that you want to know more information about what is rendering and why it's rendering. And what it will do is actually draw this blue line around the component. It'll give you a number in the top left, and it will basically say how many times I'm reloading. What's even better is if you actually click on the button right here, it'll actually say, oh, I've re-rendered twice. There was an initial render, and then some new data came in that caused me to update. And actually, as you do more interactions with this, it's actually going to tell you, oh, I'm changing because, oh, this state got updated to the leftmost object index, or I got new data in, so hence I rendered again. And this is very, very useful for bringing people up to speed on the system because they're understanding how things are flowing through your application, but it's also really useful for tuning your performance. When you want to know, like, hey, why is this happening? What kind of things should I put in my component update? This can help you tune down to say, this is exactly what's happening. I can tune that one out. I don't need to listen to that prop update and really hone in on the performance of your applications. The last thing is complex animations. And there's 3 specific examples I want to show you tonight that were particularly hard for us and how we overcame them. The first one is page transitions. You might say page transitions are totally easy, right? You throw a CSS transition group around it, your life is gravy. If you're not familiar with a CSS transition group, it comes from the basic React add-on class. You basically wrap it in any element that it's going to change, and you give it a CSS transition name. And as those components go in and out of view, it will simply apply the class. What happens, though, is you end up in situations like this occasionally. This is 2 pages overlapped on top of each other. And what happened is then the user navigated to a new page, and they came back, and the transition event did not fire, and therefore it just said, I just stick these 2 DOM elements on top of each other because that's where they are. And it never cleaned itself up. It left it in a bad state for our user. And we said, we can't count on the fact that transition end will fire correctly, and we really don't want to sacrifice the UI for the sake of an animation, right? That's not a great user experience. So we started using the Khan Academy timeout transition group. In contrast to the CSS transition group, which listens for a transition end, this one you say, you have exactly this much time to complete your animation. After that, I'm totally taking over. I'm going to flip the state because it's important that my user get to where they need to be, regardless of what kind of animation you're in. And this is especially nice when you have a page take too long to load or whatnot. You don't want the user waiting for an animation. Just get them to where they need to be. And what you do is you set up an SLA or a software license agreement to say this is exactly how long you have to get to where you need to be. You add it on that transition group. Life is pretty good. So you get a result like this. Page looks great. Go ahead and find a title I'm interested in. Click on more information in the Jawbone. All right, let's go to sitcoms. And then this happens. So the transition worked this time. We didn't get overlapping pages, but I did end up in the middle of the next page, which is kind of a problem. And this works on every router example you'll see. And the issue is React is making the minimum number of DOM changes to get you to the next page, but it's not taking into account the scroll behavior. And we said, well, we really want a nice, smooth behavior, right? And so we tried kind of the native ones where you can flip on something to say, hey, ignore scrolling between pages. But the animation simply looks like I'm going to pop you to the top of the page and there's kind of a jump, and then it does the nice fade. We said we want a much more elegant transition. So what we did is we actually used the lifecycle hooks that React gives us to extend Khan Academy's code a little bit further. And we said, okay, there's 2 things I want to modify for this. The first one is that before that new page comes in, I actually want to delay it a tiny bit, basically by 500 milliseconds, or 50 milliseconds. And after the previous page leaves, I want to do a scroll to the top. Throw those in. This is how the transition looks after you've done those modifications. Scroll to the spot we're looking for, open a Jawbone, get some context, go to this page. You'll see a nice smooth transition out and in the correct spot on the new page. And this is a much better animation for our users, allows us to do much nicer animations for that. And then we also get the benefit of the back button going to the correct spot. And it's because we modified our scroll behavior in between states, so we can say, hey, go back and you'll end up in the right spot on the previous page, which we would have lost in the other paradigm. So, page transitions. The next one was sliders. And sliders were really challenging to us because we wanted to make this website work on even low-end devices. And the ability to say, okay, there's this group of titles, and they could be potentially 100 titles long, and we want to move them back and forth on this page. So how do we do this effectively? And our first approach was to say, okay, let's do this in React, right? React will totally take care of this. So I'm going to show you the state up here in the top right and what we're manipulating. And we're going to say, all right, we're going to click on this peak over here, and we're going to click to scroll to the next row. So we'll click it. Oh, we got to render. Now we got to insert into DOM. And now we get to do that animation to move everything over to the left. From a user experience side, you're clicking on this thing and you're going, it's a small delay, but it's totally noticeable. And it's totally, it just makes you just want to yell at the computer. You're like, why are you taking so long, right? Every other carousel I've ever seen in my life is fast because they've loaded everything into the DOM. Why is this one so slow? And we said, this is no way to do it. We want to do it in a much better way. So we said, okay, let's try something different. So in this way, we're going to render what's absolutely necessary for the initial page load. And then after the page is loaded, we're going to actually pre-render the next page that you can scroll to. And let's zoom out for a minute into what's happening beyond the viewport. So we've got our initial page, and then we pre-built just enough to get you to the next screen. And we said, as soon as you click on Futurama now, we will immediately do the translate 3D of the row. Our state hasn't updated just yet. And then we'll say, after that transition occurs, hey, React, something changed. We've moved our position. Go ahead and update and pre-build the next set of items for our next movement. And this is great because we get to take advantage of CSS and the nice smooth transitions we would want from that, while eventually, right after the transition end, handing state back to React to say, well, now fix everything because this is what we modified and this is how we want to be for the next round. So when the next animation comes and I click on Friends, we once again move everything we have over and we say, React, we're now at position 10. Go ahead and strip off the initial items and pre-build our next page, and the animations go on and on like that as you're moving left and right. And we found this to be very, very performant in all the way down to our lowest end devices because we're just taking advantage of CSS Transitions, excuse me, for doing that move, and then React cleans up right over the user. And then the best part is because React is doing the minimum number of DOM changes, the user doesn't even see anything happening in their viewport. It's really a beautiful way of doing it. The last one is the Jawbone. The Jawbone was one of our most expensive animations. And once again, to get everybody on the same page, here's what it looks like. You click on an item that you want more contextual information on, and we open this up right in view. So this thing is actually 7 different animations occurring at exactly, or about exactly the same time. And to take you through it sequentially, here's everything that's going on. The first one is that we have that existing card, and we need to actually shrink that guy to be the size of the rest of the rows. Then the other titles were pushed aside, so we need to bring those in. Next, we actually need to bring the user to the correct context, which is raising the view to the top of the viewport. Next, we need to make space for the Jawbone by pushing all the rest of the items down the page, which is a translate y times n. Then we need to actually bring the Jawbone in with a small transition, fade it in, and then our 7th and final animation is to put a ring around the active title. And so this was the request that we had worked on and that we had got, and we said, okay, how are we going to solve this? And it looks pretty complex. To see it once again happening, here is it happening at pretty much the same time in an animation. Boom, all happening. So to pull it off, we had to take a really close look at how we were doing a lot of our rendering, how we were doing our data fetching, what was happening inside of the browser while we were trying to do this very, very expensive animation. So we did it by aggressively controlling almost every part of our rendering pipeline, really taking a look at what did our frames look like, what did our layers look like, how are we expensing things, what kind of things were happening while we were trying to animate. And so the first one we took advantage of was the Lifecycle Hook should component update, which React gives you, which is the ability to say, hey, you don't have to re-render unless this is true. And specifically for this one, we wanted to make sure that the rows were only being updated if the data changed. So we're fetching data all the time when we're prepping that view. And while the title might be getting more information, I don't really care at that time to update the row, right? It might get more embedded information, but I'm not showing it, so why would I re-render? So one of those little tricks is like to say, hey, if there's not new items being added or removed to this row, don't re-render. Just save that for another time. We'll do that when somebody's explicitly taking an action on that row. The next one was staggering animations. And so because we have these lifecycle hooks to say, hey, you're going to start here and then we'll hand this off here, we could actually stagger our animations to make sure that not everything was actually being thrown on the GPU or wherever it was at the exact same time. And just by staggering our animations through React, we could say, okay, you are much better off coming right after this one and putting a delay in there or putting a duration event so they all appear like they're occurring at the same time or finishing at the same time, comes out quite nicely. The next one was to control data fetching. And it's very expensive to have an animation going on and trying to fetch or receive and parse data while that's occurring. And so by controlling and saying, hey, we're trying to do a big expensive thing, let's put kind of a lockdown on the thread, not a literal lock, but just kind of saying, hey, something big is happening. We can say, let's hone in this so that the CPU is not being so bogged down right now. We don't want to cause a lot of jank while this animation is occurring. And so we're using FALCOR for our data fetching layer. I'll talk a little bit more about that at the very end. But we can control that through React by saying, hey, let's hold on while you're doing that stuff. And the last one was a small one, but preloading image assets. So when you have the ability to know where the mouse is on the page, what things are being focused, you can actually prefetch, preload, get a lot of those assets done beforehand, because the worst thing, once again, is have an animation occurring and you're saying, well, now I've got to load these assets in, and I've got to parse the assets, and I've got to build this part of the DOM. Have that stuff ready so you can build the DOM as soon as possible so that your page can get up nice and quick. So it's interesting also because what didn't work, we tried a lot of crazy stuff to see if we could beat React or change React or do different things to see if we could boost the performance. And these were things that didn't work for us in terms of performance. And the first one was grouping the rows. We said, okay, that translate y times n is a huge operation. We've got all these layers moving on the page. It's ridiculous. Let's see if we can just draw a DOM around the boxes that will be moving down the page and then move those as a single unit. And while React gave us the ability to draw those boxes around it, overall the CS animation was not fast on it. The time to actually touch the DOM, change some stuff, and then move it was simply too slow. If we just simply kept those row layers already on the GPU stack, we can move them much more quickly. The next one was just to say, if there's a lot of stuff that's not in the viewport, right? We've got 40 rows on the page, but maybe 5 are visible in the viewport this time. Let's just not render them at all. And so we tried this, and it made the Jawbone insanely fast, right? We got awesome animation because there was maybe 3 rows on the page. You did a movement. It was awesome. The problem was we traded one problem for another, because now you have the problem as you're scrolling down the page, we were trying to listen for DOM events, listen for scrolling, do rendering of actual rows, try to shove those in. It ended up being very, very slow for us. Now we haven't given up on this particular point. We still think there's something to be done about virtualization of the scrolling. So we're going to continue actively working on this, but in the meantime, we didn't see the gains that we wanted. Some people have tried some new stuff which we're very interested in trying out. And we'll come back to seeing if we can make this really performant for us, because why render stuff that's not necessary on the page? The next one was an interesting attempt to beat React. We said, we want to change some styles on the page. We want to change some DOM nodes. I bet you we can beat React's timing. And so we actually put event listeners, and we put these hooks and callbacks to say, I bet you we can beat React in terms of timing. And when we measured it, there was simply no effect in beating React. It was faster than us every time. We said, awesome, that really validates React as a platform for changing stuff. It's good to know for going forward. And same thing when we tried to just change classes directly. React was just too fast and we couldn't beat it. So, we're already to takeaways. So what are the takeaways I want to give you for tonight? First one is remembering that when you're in isomorphic context, be very careful about bringing new people in and not teaching them the best practices about working in a multi-tenant environment. We've actually written some ESLint rules to help us in this regard, checking for our pipeline to say, hey, are things being modified on a global scope? And if so, you better warn the user that they're modifying something, because maybe they're not aware of it, but education is very important when bringing people up to speed on this. The next one is CSS transitions are really, really fast. They're already optimized for your GPU, so take advantage of them when you can. React doesn't have to be in charge of the state all the time. You can hold off for a little bit, make the trade-off to say, I'm going to do this animation my own way, and then hand it back to React. And this has worked out really, really well for us. And then lastly, Lifecycle Hooks. React has given us a ton of Lifecycle Hooks. Component will enter, component will leave are little known ones, but everything going on in your system has a hook and a callback. And by really hooking into these things and controlling your pipeline, you can achieve a lot of complex animations and a lot of really great stuff out of it. The last thing is that I've talked about FALCOR. FALCOR is our data modeling layer and data fetching layer that we've been working on open sourcing. We use this as the backbone for building our new UI, and I'm excited to say it's going to be re-released very, very shortly. We actually have Michael Paulson in the back. If you have questions about FALCOR and when it's coming out, you can totally ask him. So lastly, these are the links to the stuff we talked about. The React Visual Renderer is the thing that shows you, it's a mix-in on any component. We'll show you what's updating and why. The Timeout Transition Group is our modification to the Khan Academy's transition group that gives you hooks for entering and leaving. And then the ESLint plugins I mentioned as far as watching out for global context are here as well. So this was totally not just me working on this. This was a group effort over a long period of time. I have some co-workers in the audience who also helped working on it. If you could raise your hands. Feel free to ask me or them any questions about how we built it. We'd love to talk about it. And with that, are there any questions?